In Part 4 of the Unit 3 notes, we will be covering drawing Bohr models. Niels Bohr, a Danish physicist working in Rutherford's laboratory in 1913, proposed a quantum model of the atom which explained where electrons could be found outside of the nucleus. It is a slightly modified version of the Rutherford model, which places electrons into shells based on energy level. Each shell can hold a different max number of electrons. So in our Rutherford model, we had a nucleus with protons and neutrons in the center and electrons somewhere outside. So this model is going to be a little more specific in exactly where those electrons are. Now for each of our shells, they may hold a different number of electrons. So in shell number 1, the one closest to the center of the nucleus, that shell can hold a total of 2 electrons. In our second shell, we can hold a maximum of 8 electrons. Our third can also hold 8, and then it goes 18, 18, 32, 32. So you do not necessarily have to reach that maximum capacity for the shell, but that is how many electrons could fit inside of it before they would have to kind of spill over into the next shell. To create a Bohr model, you should begin by drawing a circle depicting the nucleus. List the number of protons and neutrons inside of the nucleus. You will then draw the appropriate number of rings based on the number of electrons that are present in the atom. Now, if you did an internet search for a Bohr model of oxygen, you would find one similar to the one that is shown over here on the bottom left. But we will not be drawing it in this way. We're going to make a slight modification. Now for ours, we're still going to have our circle. We're going to put our protons and neutrons inside. Here we have 8 protons and we have 8 neutrons. For our shells, instead of putting a circle all the way around and putting dots, we're going to put a little half circle with space in the middle to fill in a number. And since there are 2 dots here for 2 electrons, we're just going to write in the number 2. It makes it a little bit faster for you and also easier for both of us to be able to read it. For our second shell, it can hold a maximum of 8, but you can see from this diagram that there are only 2, 4, 6 before oxygen runs out of electrons. So we're just going to fill in the number 6 here. So this is the way that I would like you to fill them in for our class, even if you do a Google image search and you find something similar to this. For our first checkpoint question, we are going to be drawing Bohr models for 3 different neutral elements, and we've been given the number of protons, neutrons, and electrons for each. Eventually, you will have to figure that information out on your own. We'll start off with potassium. Should always make sure that our Bohr models are labeled. So this is for potassium, which is K. Protons are going to be equal to 19. And neutrons are going to be equal to 20. Now we have 19 electrons here. Our first shell can hold a maximum of 2 electrons. So I fill in 2, and then in my head I'm thinking, okay, I had a total of 19. I just used up 2. There's 17 left. All right, so I fill in the next shell. That can hold a maximum of 8. So far I've used 10 of my total 19 electrons. So I have 9 left. I'm going to put 8 into that third shell. So I've used 18. There's 1 electron left. That next shell can hold up to 18, but I only have 1 left. So this is what I would have you draw for a Bohr model for neutral potassium. All right, gallium I'm going to write out down here. So we have gallium. Protons are equal to 31. Neutrons are equal to 39. For our first shell, we are going to fill in the 2. Then we have 8, 8. So that's a total of 18 so far. And we still have 13 electrons left. All 13 of those electrons can fit into my next shell, which has a maximum capacity of 18. For my final element, we're going to fill in phosphorus. Protons are equal to 15, neutrons are equal to 16. you can fit 2 in the first shell, 8 in the second, so I've used up 10 so far, and I only have 5 electrons left. So they're going to go into the third shell. So I do not need to write out any shells that I do not actually start to fill. All right, for our next checkpoint question. Now we're going to do the same thing. We're going to draw Bohr models, but now we're starting from scratch. So we need to figure out how many protons, neutrons, and electrons each of these has first. First, for the protons. The atomic number is 22. So I know I'm going to have 22 protons. Remember, there is no neutron number on the periodic table, so I'm not going to find the neutrons here explicitly. But I can see that the total mass is about 48. I have to round that to a whole number to make it the mass number. 48 minus 22 will give me my neutrons, which is 26. This is still a neutral atom, so we're going to say that there are 22 electrons. All right, now for the Bohr model portion of this. Protons are going to be equal to 22. Neutrons are equal to 26. We have 2 in the first shell, 8 in the second, 8 in the third, so I have 18 out of 22 so far. And my last shell is going to hold 4 electrons before I run out. For the next atom, we have aluminum. Protons are going to be 13 because that's the atomic number. Neutrons are going to be 27 minus 14. So the total mass is 27 if I round that up. 13 protons, so that's going to be 14 after I subtract. And the electrons are going to be 13 because this is a neutral atom. So these two are going to have to match. Protons are going to be equal to 13. Neutrons are equal to 14. 2, 8, and then 3 for my 13 electrons. That concludes part 4 of the Unit 3 notes on drawing Bohr models. When we come back for part 5, we will be looking into ions.